next we move on to making the decision. I think I've already alluded to this with finding the critical values before, but it doesn't hurt to state it a little more formally. So once we find that critical value and compare the test statistic to it, we have to make a decision about the hypothesis. Our options are to reject the null hypothesis or fail to reject the null hypothesis. And be really careful. We never say accept the null hypothesis. Some older textbooks might say that, but we don't want to use that language because it sounds like we're proving the null hypothesis, which is not really the case. We're just disproving the alternative, if that makes any sense. So either we reject the null hypothesis or we fail to reject the null hypothesis. If the test statistic falls in the rejection region, we will reject the null hypothesis in favor of the alternative. So just as we showed above, whatever my rejection region looks like, if I fall in the rejection region, then I would reject the null hypothesis. But if the test statistic does not fall in the rejection region, we fail to reject the null hypothesis. So whether I'm two-tailed or one-tailed, that part doesn't matter. But let's say I had rejection regions here and here. If my value falls here, then I do not reject or fail to reject the null hypothesis. So here we would reject the null hypothesis. Okay, now in all of this, there sure is the possibility of an error. So in reality, the null hypothesis may or may not be true. We really don't know. If we reject the null hypothesis when it's actually, if we reject the null hypothesis when it's false, then we did a good job. Similarly, if we fail to reject the null hypothesis when it's actually true, then we made the correct decision. But what if we are wrong? Making an incorrect decision is referred to as an error. So this chart kind of helps you wrap your head around when you've made a correct decision and when you've made an error. So if my action, if after all doing all my testing and comparing to critical values and all that, if I reject H naught when it was actually false, then I made the right decision. But if I reject it when it was in fact true, that's an error, and that's called a type 1 error. So if I reject when H naught was really true, then that's a type 1 error. If I do not reject H naught when H naught is true, then that's the correct decision. But if I reject H naught when in fact it was false, that's a type 2 error. So if the null hypothesis is indeed true, but we reject it and say, no, it's wrong, then a type 1 error is made. The significance level alpha is the probability of a type 1 error. So you'll see those two used together. If the null hypothesis is false, but it's not rejected as it should be, then that's a type 2 error. And the Greek letter beta represents the probability of a type 2 error. Let's just put this in context. Maybe that'll help us to understand the difference between a type 1 and a type 2 error. A soft drink filling machine is set to dispense an average of 20 ounces of product into single-serve bottles. A quality control manager thinks the machine is not filling properly and might need to be adjusted. State the null and alternative hypothesis where mu is the mean volume of product of all single-serve bottles. Explain the type 1 and type 2 error. Okay, so the null hypothesis is saying, yep, the average that goes into each bottle is 20 ounces. But the alternative is saying, well, and this is the quality control manager saying, I think there might be a problem. I don't think it's filling at 20 ounces. Now, an indication of direction was not mentioned. The quality control manager is not saying if it's too much, and it's not saying if it's too little. We're both cases what cause a problem. If it's filling too much, then we're wasting money because we're giving away free product. But if it's not filling enough, then our customers would be upset, and that would hurt business as well. So we just, since we don't know, we just put not equal to. Okay, so a type 1 error would be we reject H naught when it is true. So in the context of this problem, what we're saying is we conclude the machine is not filling properly when in fact it really does. So type 1 in the context of this problem is saying we do all of our calculations and we're saying, oh, no, it's not filling properly. And maybe we have a tech come out and fix it and do all these type of adjustments. When in fact maybe it really was filling at 20 ounces and we just made an error in our calculations or something went wrong. So that would be an example of a type 1. We make the wrong conclusion when it's really true, when H naught is really true. Type 2, we do not reject H naught or fail to reject is a better way to say it. When it is false. So here what's happening is we conclude that the machine is filling properly. This should be not up here. We conclude that the machine is filling properly when really it is not. So in type 2, there really is a problem and we don't catch it. So we're saying, oh, it's fine, it's filling at 20 ounces when maybe some shipments go out and they're not quite 20 ounces or maybe they're a little bit above. So this mistake here is we fail to reject H naught when H naught really is false. Type 1 is we reject H naught when in fact it is true. So it takes a little bit to wrap your head around those. Another way to think about it is in terms of maybe someone on trial. So someone could be convicted of being guilty or not, but then there's the reality of did they really do it or not. So let's say the null hypothesis is that the defendant is innocent and the alternative is that they're not, that they're guilty. Well, let's say the jury is convicted, but the person didn't really commit the crime. That would be a type 1 error. But if the defendant is acquitted when he or she did not commit the crime, that's the correct decision that's made. Also, if the defendant is convicted and they really did do the crime, then that's also the correct decision. But if the defendant is acquitted and they did commit the crime, then that's another error. That'd be a type 2 error. So maybe that's another way that can help you understand type 1 and type 2 errors.